Here's what we do. We will set up.
This is tunnel vision.
From planet to planet. Solar system to solar system. From galaxy to galaxy.
Oh, well. And these are my lovely assistants, Betsy.
Hi.
And SELMA. And today we're going to be learning about aqueous solutions. So in our solution we have two reactants, which is the powder and the water. And the way this works is we're going to start with the water by pouring it into the bowl to make our mixture. Next we pour the powder. And as we mix it, the powder dissolves, forming our aqueous solution. Aqueous solution.
Another public service message from way out.
So we're going to be talking about 5 different chemical reactions: synthesis, decomposition, single replacement, double replacement, and combustion. In a synthesis reaction, for example, we have hydrogen reacts with chlorine to produce hydrogen chloride. So this is your skeleton equation. And what you do is you look at the elements on the periodic table and you just write down their symbols. But now you have to balance the equations. Since hydrogen and chlorine are both in Brinkelhoff, that means that they both need a subscript of 2. And now to balance the equation, you need 2 of each on each side. So if you have 2 hydrogens on one side, you need 2 hydrogens on the other side. And that 2 distributes to the chlorine as well, balancing out your equation. So the main rule you have to remember is that you can only change the coefficients. You can never change the subnumbers. And this is the chemical equation. So in a decomposition reaction, we're going to use potassium chlorate yields potassium chloride plus oxygen. The reason why we have KClO3 is because chlorate is actually a polyatomic ion and it's written out as ClO3. And since O, which is oxygen, is in Brinkelhoff, that means it has to have a subscript of 2. Now you have to balance out your chemical equation. And the way you balance it out is you balance out the oxygens, because there's 3 oxygens in ClO. Then you balance out the potassium and the chlorate, which is 2 of them, and it balances out on the other side. And this is what it looks like. AB yields A plus B. Next we have single replacement. For our single replacement, we're going to be using silver nitrate plus nickel yields nickel nitrate plus silver. What you do is you multiply the second atom or compound that you have by the next one. So we're moving nitrate over to nickel. And the way you know this is by looking at the activity series. You have to see the most active and the least active elements. And since silver is less active than nickel, then nitrate is going to have to move over to nickel, because what they like to do is go to the more attractive elements. And this is what it looks like. AX plus B yields A plus BX. But there are some situations where you do have no reaction. In double replacement, we're going to use hydrochloric acid, reacts with sodium hydroxide, yields sodium chloride and water. In order to complete this reaction, you do something kind of like distributing. It's sort of like algebra. You multiply the last 2 and then the ones in the middle, giving you NaCl plus H2O. And the reason why it's H2O is because you have to combine them. There's a subscript of 2 because hydrogen has a +1 charge and oxygen has a 2- charge. So it makes the equation balanced by using 2 hydrogens and 1 oxygen. And this is what it looks like. AX plus BY yields AY plus BX. In a combustion reaction, you have methane, which is CH4 plus oxygen, which yields carbon dioxide and water. So what we have is O2 plus CH4, and it's O2 because O is in Brinkelhoff, like we've been discussing. Then you balance out your equation, and all the combustion reaction is hydrocarbon plus air yields heat and water. And that's it for our chemical equations.
We care about your world. Stay tuned.